All right, welcome to Unit 7 test review. This is for A, B, C, D, and E, F. I'm going to work on certain problems here, and the answers are all in the back, so you can always check your answers. But I'm going to pick out certain problems that should kind of go along with any other problem. There should be other problems on the page just similar to this. So the first one, we have a trinomial. That's what number 3 I'm going to do. We have a trinomial that is being subtracted by another trinomial. So first thing I'm going to do is with the parentheses are meaningful here because we're subtracting each term inside. So we're subtracting each term. On the first parentheses, there's no subtraction, no multiplication, nothing in front of the parentheses. There's no exponents, so we don't actually need the parentheses there. So we can drop the parentheses in the first. And I see that it's not written properly from biggest exponent to smallest terms with biggest to smallest, but that's okay. We'll do that at the very end. So we're going to subtract 2n to the third. We're going to subtract 4n. And we're going to subtract n to the subtract n to the fourth. I'm going to look at what my like terms are. So biggest exponents first. So we have 6n to the fourth, and we subtract n to the fourth, and that is going to be, remember that's a 1. So that's going to be 5n to the fourth. So that's the biggest exponent. Now let's work down to this next. We have positive 2n to the third, and we're subtracting 2n to the third. We have 2n to the third, and we subtract 2n to the third. That's 0. So we don't have to actually write that because it's 0. And then we have a squared term. That's only 1. It's a positive 3, so plus 3n squared. And then lastly, we have minus 4n. So here's our final answer. Good morning. We have a trinomial, 3 terms. And then first we're going to start with the exponent. The biggest exponent of a term is in, and this is in standard form now. There's no addition, subtraction, no simplifying that I can do. Not in factored form. So it's a 4th degree. There's no special name for 4th degree or 5th degree that we really talk about. 4th degree, and it actually has 3 terms. 4th degree trinomial. So it's a 4th degree trinomial. So that's 7a and 7b. All right, number 5. I know fractions are not always our friends. So first thing you do with fractions, we can't be scared of them. We look at the denominators, and we're adding here. So when adding fractions, you have to have like denominators. So we got to figure out what can we do to each. What would be our common denominator? Well, 3 and 6. 6 is going to be our common denominator. So our first fraction, I'm going to multiply the numerator and denominator by 2. It's like you're unsimplifying it. Second fraction, I'm going to multiply the numerator and denominator by 2. We don't need 11/6 to be changed because it already has the denominator 2. I'm going to multiply the last fraction by 2 to get come on. And now look to see, do we need to have the parentheses for any reason? There's nothing in front to multiply or subtract, no exponents, so the first parentheses are not needed. I want to write with a highlighter. So 4/6x squared minus 8/6, and then we're adding. When you add, it doesn't change anything to the term, so we really don't need the parentheses here. Parentheses weren't needed. All right, let's look at what we have. We have 4/6x squared, and we're adding 8/6x squared. When you add fractions, you get the like denominators, which we already have, and we add the numerators. So our answer here would be our 14, so 8, no, not 14, 12. 12 over 6x squared. Now we have like terms also with the constant terms. So we have negative 8 plus 11 is 3/6. Now after you combine, we see, can we simplify? We have 12 divided by 6 is 2, and 3/6 can reduce to 1/2. All right, so now we have, it is the biggest exponent. The term with the biggest exponent is a 2. That special name is a quadratic. And there are 2 terms, so it is called a binomial. 2 terms. All right, let's take a look at number... We're going to cut some problems out here. I'm going to look at number 7 first. And not this number 7. Let me see what I can do to get a new paper in here. Number 7. And we multiply here. We have 6x squared. So we have a trinomial times a binomial. So you can do a Punnett square if you'd like. I'm going to just distribute 6x times 4x, 24x to the third, 6x squared times 4, 24x squared. Then we have a negative 5x we're going to distribute to both terms in the second binomial, the binomial. Negative 5x times 4x is a negative 20x squared. Negative 5x times 4 is a negative 20x. Now we have one more term that we have to distribute. So negative 7 times 4x is a negative 28x. Negative 7 times 4 is a negative 28. After you multiply, now we look to simplify. Do we have any like terms? Do we have a like term with a 24x to the third? We don't have any other x terms with x to the third, so that is 24x to the third. Now we look to see, do we have others? We have 24x squared. We have another x squared term here, so we have 24x squareds, and we subtract 20x squareds. Together we would have 4x squareds left. Here we have a negative 20x, and we subtract 28 more x's. Well, that would be negative 48 x's. And then our last, we have a minus 28, the constant term. Now we look at our exponent. The biggest term with the biggest exponent is the 3, the cubic. So that tells me it is a cubic. And how many terms are there? There's 1, 2, 3, 4 terms. So it's a cubic 4-term polynomial. Typically, no one uses it. I'm sure there's a actual term, a name for it, but I don't know anybody that really uses it, so I'm not going to talk about it. All right. We have... Hello. Now I'm going to do number 7, which is actually number 9. So for this, finding all the roots. Roots, another name for root is solutions or x-intercepts. And to find this, right now the x to the 4th minus x squared minus 42 is in standard form, and it kind of looks like a quadratic, so we can factor it. So what we're going to do, when a is 1, we do what 2 numbers multiply to c that add up to b. And what 2 numbers would be multiplied to negative 42 that add up to negative 1? That's negative 7 and 6. Now, when a is 1, you can do a quick factor. To get x to the 4th, break it up with an x squared and x squared. And then it's minus 7 and a plus 6. So only when a is 1 can you do the shortcut. Now, to actually find the roots or the solutions, we need to set each factor equal to 0. And solve. Oh no, sorry. I don't know what happened. We have x is going to equal a positive negative. The square root of 7 cannot simplify, so there's 2 answers, a positive and negatives. And now we have a negative 6, or subtract 6. Square root. When you use square root, you get a positive and negative. And now we have a positive negative. The square root of a negative is I, square root of 6. And there are my other 2 solutions. All right, number 11. I haven't done a lot of problems like this, mainly because, well, they're fairly simple. You have 4 terms. Anytime you have 4 terms, we can try Can't say it always works, like factoring doesn't always work, but if you have 4 terms, well, you have 4 boxes in the Punnett square. So I'm just going to put first term top left, last term bottom right, and the other 2 terms in the other boxes. And now let's take out our greatest common factors. Bottom left would be 1, and because the bottom left box is negative, it'll be a -1. Top left will be x, or top row. Last column will be -1 again, and the first column will be x squared, the smallest of the two, x to the third and x squared. X squared is smaller. All right, so those are our factors. All right, let's set each factor equal to 0, and then we gotta solve. So the first one, add 1, square root, don't forget about the plus minus. Square root of 1 is 1, so we have a +1 and a -1, and then on the right side here we're going to get x equals +1. Well, we have a +1 here, and we have a +1 there. That means it's double, so I'm going to rewrite this as x equals 1, and this is a multiple of 2. There's 2 of them, or you could say it's a double, and then you also have x equals -1. That would probably be the best way to write that. All right, moving on. Number 15. So here we have, it's factoring again, quadratic like, but now a is not going to be 1. Now a is going to be 3. So we have a, b, c. Here we're going to do a times c, which is 84. 3 times 28 is 84. And it's going to add up to -19. To get 84, I'm just going to start with 3 and 28. And then I'm going to play around. Those add up to 31. That's not going to work. We need to add up to -19. So I'm just trying to figure out 2 numbers that are the difference of them. So subtracting them would be 19. And that's the numbers we're going to have. So actually, hold the phone. They have to multiply to a +84. So that means 2 negatives would have to add up to -19 that have to multiply to 84. Those are the rules. So really we're just looking at, I can look at the positives and just make sure they're negatives if they add up to 19. So right now we have 31. We need -19. So what I'm going to do is take 28 and divide by 2. That's 14. So I multiply 3 by 2, and that's 6. Well, that's 6 and 14 add up to 20. That's close, but it doesn't quite work. So I'm going to take 28 and divide by 4. So that'll be 7. And 3 times 4 is 12. Well, 12 and 7, those multiply to 84, and those add to 19. So all we really need is put negatives on those, and that'll multiply to a +84, and they'll add up to -17. Now, a is negative, so we're going to have to use the Punnett square. And so top left is a term, bottom right is the c term, and the 2 numbers we just came up with, we're going to split up the b term. So x squared and then -7x squared. Take out your greatest common factor. The bottom row would be 4, and because the bottom left is negative, I'm going to take out a -4. Top row is x squared. First column is 3 and x squared, and last column is 7. And because the top right is negative, it's going to be negative. All right, let's set each factor equal to 0. And solve. Oh, I don't know what I'm doing. Let's see, square root. Positive, -2. There's 2 answers. And now with this other one, a little bit more work to do. Divide by 3. And now when you square root, we have to, you're actually going to see that the square rooting, you have to, if there's a square root in the denominator, we have to get rid of that square root of 3. To get rid of it and make it a rational number in the denominator, we multiply when it's a monomial. So you have x equals a +negative square root of 7 times the square root of 3 is 21, over 3 times 3 is 9, square root of 9 is 3. Square root of 21 cannot be simplified. There's no biggest perfect square that can divide out of it, so that's actually your final answer. So there are your 4 answers. All right, so that's 15. Oh, wait, that actually is 15. Sorry for this confusion. I don't know what happened with my papers. And I'm going to do 19. I'm actually going to do this with synthetic division. So a plus 2 is what you're dividing by. Set it equal to 0 and solve. So in the little box, you're going to have a negative 2. And I'm going to have now my coefficients 1, 11, 13, and negative 7. Look at your exponents 3, 2, 1, and then this is actually technically to the 0. So we didn't skip any terms, so I don't have to put zeros in there for anything. Write the 1 down, bring it down. First term, negative 2 times 1 is negative 2, and add, that'll be 9. Add vertically. Negative 2 times 9 is negative 18. 13 plus negative 18 is negative 5. Negative 2 times negative 5 is 10. Add. Now the last term is always our remainder. We started out with to the third power and we're dividing by a. So a to the third divided by a is a squared. You can always go down by 1. We have 1a squared plus 9a to the first minus 5 with a remainder of 3. We don't actually need the 1 there in front. With 1 times a squared is a squared. So this is our answer. And then our last thing is it a factor? Well, because there's a remainder, if there's ever a remainder, then besides 0, then no, not a factor, because it has a remainder. So a plus 2 is not a factor. So that's the last part of this. All right, I'm going to look at number 20. Oh, wow, these changed. Okay, let's do a new sheet. It's number 23. I'm going to do this with long division. 8m to the third, no, m squared, so they're all going down by 1, so I'm not skipping any terms. So I do first term divided by first term, and that is m squared. Oh my goodness. M squared, and now I multiply back down. M squared times 8m is 8m to the third. M squared times 9 is 9m squared. And now I gotta subtract. Subtract the first terms, m squared, and then the second term, so m squared minus 9m squared is negative 8m squared. Bring the 71m down. Now I'm gonna do first term, oh my goodness, divided by first term, and that is a negative m. A negative m times 8m is negative 8m squared. Negative m times 9 is a negative 9m. Now we got to subtract. We got to be careful with these because we got a lot of subtractions and negatives. First terms will cancel. 71 minus negative, that's a plus. So that becomes 80m. And let's bring that 96 down. Now we do first term divided by first term. So that's 10. And so that'll be a positive 10 up top. 10 times 8m is 80m. 10 times 9 is 90. And now we subtract, and we get 9 as a remainder. So here's one of our answers. There's our answer. And then is it a factor? No.